Hi guys, and welcome to STEAM Week. Mrs. Campbell here, and in this section of the video I'm going to be talking to you and explaining why the mission to Mars, the recent mission and the landing of the Perseverance rover, is so important. So let's start with a little bit of background on Mars. As you can see behind me, it's a bright red planet which we could only see very far as a tiny little speck in the solar system until telescopes were developed in the 1800s. And then for the first time, we could see the patterns and the shapes and all sorts of information on Mars. However, we at that time thought they were Martians because we thought all the little shapes looked like a community or a civilization of Martians. We now know that's not true. So what's been happening? So since the 1960s, we've been sending up spacecraft. Different countries all over the world have been sending up spacecraft to explore and find out more information about Mars. To date, a spaceship has never landed on Mars, but we have, for the first time, through NASA's space station in America, landed a rover, which is like a little robot, and it's landed on Mars' surface. It landed this year on February the 18th. It was the first time a robot, which we were able to program and determine where it was going to go, has landed on that planet. So it's so exciting. So at the end of this, I'm going to show you some footage from NASA space station where all the team were watching this and counting down for it to land on the planet because it's very unstable. It's very difficult to get through and land safely. And the jubilation when it did land. So fantastic. So why is it important? Well, we believe that there was perhaps some life on Mars billions of years ago. I think it's something like 4.5. You'll see this in an extra bit of video that follows this. And they believe that there was a water source, there was microorganisms living there, but there was a big change, a big shift in the planet. Something happened to create what's there today, which is a very, very dusty, dry planet with very little water. They think there's some embedded and locked into the ice, polar caps, but apart from that, there's very little available. But they do believe, and they found through satellite imagery, there are volcanoes that used to exist on there, bigger than any other country on Earth. And there's a huge crater, this whole size of America on there as well. So there's loads of information we could gather from this. So why is it important? Well, understanding more about Mars could allow us to understand more about our planet too. So there was a huge change, a radical shift in the ecosystem, in the planet itself. And there's lots changing on Earth too. There's lots of things in the news about changes to our climate and the impact we have on our world. And we're all learning about that at school. And learning more about Mars could enable us to understand our planet better too. But the second thing, which really interests science, is would it be ever possible to exist on this planet? Now, that's confounded people forever. Did people exist in it? Could we exist in it in the future? And that's another thing that the scientists are trying to explore. So this beautiful little robot called Perseverance rover is busy there, sending images back through satellites to Earth, which you can look at. If you go onto NASA's website, you can look at live footage of what's happening on that planet right now. And we're going to take soil samples and lots of imagery, and then astrobiologists can then look at that and examine those and understand what processes were involved, what happened over time, and what could possibly happen in the future. So very exciting. So no spaceships have landed yet. That's what we perhaps could explore, designing and exploring as an idea of how and what we could innovate to do that. This week's all about innovating for the future. And this is why this works beautifully with this project and what we'll be learning about in school. So the idea is by 2030, spaceships could land possibly on that planet. And right now, they're developing rockets to do exactly that. There's one called Orion, I believe, that's in development right now. But you, as children, as innovators, as artists, I'm saying that as an artist, of course, have a wealth of imagination, experience, and brilliant brains to use together to see where we can go with this, see what we can do in our classrooms and explore and have fun with that. So, great, I shall leave you now. The next bit is a little video I found on the National Geographic website. I think it's beautiful as explaining and showing the imagery of this planet. So watch this, and then at the very end, you will see a short segment of the Perseverance rover landing on Mars and the jubilation in the NASA space room on watching this and waiting for it to land and eventually it landing and everyone being so excited about it. So I can't wait to show you all this. So sit comfortably and enjoy. Thank you.
To the ancient Romans, the planet Mars was symbolic of blood and war. But to many people today, the red planet may hold the key for a bright new future for humanity. The story of Mars began about 4.5 billion years ago when gas and dust swirled together to form the fourth planet from the Sun. Mars is the second smallest planet in the solar system, with a diameter just shy of the width of Africa. In fact, its entire surface area is similar to that of all of Earth's continents combined. Much like its terrestrial cousin, Mars is dense and has a rocky composition. At the center of the planet is a core made of iron, nickel, and sulfur, which may have created a protective magnetic field during Mars's earlier years. Enveloping the core is a rocky mantle made of silicate minerals and a crust rich in iron. These iron minerals react with the trace amounts of oxygen in Mars's atmosphere and rusts, giving the planet its signature reddish hue. While its blood-like appearance inspired the ancient Romans to name Mars after their god of war, the planet's rusty color could be considered symbolic of the planet's prime days long past. Today, Mars is dry, desolate, and cold, with temperatures dropping as low as negative 225 degrees Fahrenheit. But billions of years ago, the planet was much warmer, more geologically active, and had a watery surface. Lake beds and river valleys snake along the face of Mars, indicating that liquid water was, for a time, present. Volcanoes, such as Olympus Mons, the largest volcano in the solar system at 3 times the height of Mount Everest, once erupted lava. But by about 50 million years ago, soon after Earth's dinosaurs died out, Mars's volcanoes also went extinct. Water on the red planet still exists today, but mostly in the form of polar ice caps. Because of factors such as the presence of water, some scientists believe life may have existed on the red planet, and may exist again. Since the 1960s, space programs from around the world have launched missions to Mars in attempts to understand the planet's past, present, and potential for sustaining life. Life on another planet may well be out of reach for the near future. But if any planet could give us hope, Mars may hold the key to the survival of humanity.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Alpha indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.